Welcome to Syntax, a Generative Introduction, 4th edition. My name is Andrew Carney. I'm a professor of linguistics at the University of Arizona. I'm the author of your textbook, and I'll be leading you through this series of video tutorials.
Hi, welcome back to my channel. I haven't made a video in a long time. However, I thought it was important to address some questions that have recently come up with respect to AI models of language, in particular those called large language models, which an example of which is ChatGPT, which has taken the media by storm. Several people have asked me, what do we take large language models to mean when it comes to generative grammar? Generative grammar is effectively a non-probabilistic, a deterministic rule-based model. Large language models are probabilistic statistical models. And given the success of programs like ChatGPT, it becomes a legitimate question, do AI-based models, statistically based AI models, falsify generative grammar? So I wanted to address that question for people. So let's start off with the question of what is a large language model? A large language model, like ChatGPT and others like it, is part of an artificial intelligence research, and it uses statistical frequency to mimic human language. With today's LLMs, you can get extremely sophisticated responses that appear to be almost human-like. In fact, they're deceptively human-like. So, how do they work? They use extremely large databases of human-produced language, which is the model in the large language model. The large database part of this is the large language part of it. These databases are then run through multiple algorithms to make predictions about what words should be used and how the words should be put together. So it's based entirely on statistics of what words typically occur together and how they occur together. If you want to read some details on LLMs, I've got a link there that I'll also put down in the comments section of this video. Now, it's worth noting that these large language models are incredibly sophisticated. They do amazing things. So, for example, I asked ChatGPT, by the way, I was using ChatGPT 4, to write a limerick about generative grammar. There once was a theory quite clever, of grammar that's generative, however. It proposed rules so precise to create language nice, Chomsky's theory will be remembered forever. It writes poetry. Not necessarily great poetry, but it writes poetry. Here's another example. I asked it, with a little bit of hubris, to write a sonnet about me. In the halls of linguistic inquiry, one name shines bright like a guiding star, a scholar whose intellect is fiery, whose passion for syntax knows no bar. Andrew Carney, the man of the hour, whose mind is a treasure trove of knowledge. He weaves theories with analytical power, bringing to light the hidden threads of language. From the depths of generative grammar to the heights of minimalism's peak, he fearlessly ventures, without stammer, to unravel the secrets that language keeps. Oh, Andrew Carney, your work inspires, your wisdom kindles linguistic fires. Now, who could resist that? It's a little bit unctuous, but that shows you the sophistication of the system. Here's another example of something that ChatGPT generated. I asked it to tell me about the theory of constituency. And now, quite interestingly, it did a really good job. So if you read this paragraph here, the linguistic theory of constituency is a fundamental concept in syntax, which aims to explain how words combine to form phrases, clauses, and sentences. According to this theory, words are grouped together into phrases that function as a single unit or constituent, which can then combine with other constituents to form larger structures. This is practically the definition that I gave in the textbook and in our videos. It even talks about implications. The theory of constituency has important implications for our understanding of how sentences are structured and how meaning is conveyed in language. Now, this is particularly interesting, of course, because ChatGPT does not use constituency. It is not a system that is set up to make use of recursive rules like phrase structure rules or X-bar theory. It's based on statistics and probabilities, not upon rules that develop that structure abstract structure. Nonetheless, ChatGPT can put together quite a coherent description of the theory of constituency. Now, I'm going to address the issue of how that plays out with generative grammar in a moment, but I do want to take a moment to, as an aside, to talk about ethical issues that arise with large language models. So, first of all, they're not particularly careful with the facts. So here is a piece of text that I asked it to generate about my colleague Heidi Harley here at the University of Arizona. And it generated a very interesting biography of her. Some of it is correct. She is a linguist and professor of linguistics here. She did study at MIT. She is known for her dedication to teaching and mentoring students. She did write English words, a linguistic introduction, and she's an active member of the linguistics community. All those things are true. But there's also a lot of falsity in this description. So she wasn't born in 1964. That ages her by 5 years. She wasn't born in New York City. She didn't grow up in New Jersey. She didn't complete her undergraduate degree in philosophy and French at Wesleyan. She actually studied in Newfoundland. She didn't receive her PhD in 1992. It was 1995. And interestingly, it said with a dissertation on the syntax of Irish. Her dissertation was actually on the syntax of Japanese and English. It was my dissertation that was on Irish, although we graduated in the same year. She also didn't win the 2007 5-Star Faculty Award. She did win a graduate teaching award, however. It's just not that one, and it wasn't in that year. This is one thing that we find about these large language models, is they're not particularly good with the truth. When I generated one about myself, which I have not put here in the slideshow, it said I was born in Scotland. I wasn't. I was born in Canada. It had me being an assistant professor at the University of California, Santa Cruz. I wasn't an assistant professor there. I was a postdoctoral fellow. It actually claimed that I played the accordion. I do not. And it claimed that I had several successful albums of accordion music, which is also, I assure you, not true. So you have to be very careful with them. They write things that sound very convincing, but they write things that are overtly false. It's also worth noting that some of this information is actually available in public sources. So, for example, Heidi's educational background is in her Wikipedia article, as is mine, as is my birthplace. None of that is reflected in what ChatGPT put out, even though it's actually out there on the web, which is the data source that ChatGPT uses. So that's one ethical issue. The other ethical issue is they don't have any ethics. So it's well known that if you bias the model by providing it with sentences with very particular content, you can actually have it produce things that are racist and homophobic and sexist. There have been AI systems that have had to be shut down because they have been sort of taken over by people who have fed them data that makes them even do things like encourage violence, child abuse, and genocide. And those LLMs have had to be taken down and taken away because they were trained in such a way that they had very biased and dangerous points of view. It's also the case that people can use them to cheat on papers and disguise the fact that they didn't write something. So they can be used as plagiarism tools. So Because it's a computer program, it doesn't have any ethics. And it's up to the humans who use it to apply ethics to its use. Nevertheless, that is certainly a big challenge to these things. I've given a link here, which again I will put down in the comments section, that you can click on to read more about this particular issue. Okay, ethical issues aside, the question now comes up about whether or not large language models are in fact good tools for describing human language, and are they a legitimate competitor to generative grammar? So there are two main properties that directly contradict the tenets of generative grammar that we find in LLMs. The first is they are given no universal grammar. They're given no sets of parameters. They're given no sets of constraints over what a language should look like. In theory, you should be able to feed an LLM a non-existent human language, and it will acquire it, even if it is inconsistent with what we know about universal grammar. The other thing that these do is they don't use structural rules that describe constituency. They're based, as I have said before, on the frequency of co-occurrences of words. So they are probabilistic and statistical, rather than deterministic and rule-based. So these two things are sort of critical components of generative grammar. Having access to a universal grammar underlying system for acquisition, and using structural dependent rules. So LLMs seem to use neither of these. Does that mean that they are that those two parts of generative grammar are false? Is it really the case that there is no universal grammar and there is no structural dependency? Okay, so let's address both those questions in turn. Now, I will, before I start on this, I will acknowledge my own biases here. I am a generative grammarian, so I'm going to take a particular take on this. If you find a linguist who is particularly interested in statistical modeling, they will give you a very different answer. However, I think the issues I'm going to raise here are valid and merit debate and intellectual questions. So, first of all, are LLMs proof that you don't need a universal innate grammar? Could humans acquire language using the tools that LLMs use? So, part of the problem with this is that they are, by definition, large language models. They need access to extremely large corpora of data in order to draw the inferences, the statistical inferences they make about sentence structure. You see this actually if you compare different versions of ChatGPT. Version 3 is not nearly as good as version 4. And the primary difference between the two is the very large increase in data that have been fed into the model. So the ChatGPT 4 works really well, partly because of the vast amount of data that it has. Now, let's think about what universal grammar does for a child acquiring a language. Now, it's simply the case, and it's not hard to prove this, that children do not have access to large databases of language input. Like, they don't have access to every English sentence ever published on the web. It seems to be the case that's been well demonstrated in language acquisition studies that children make decisions about the structure of their language based on very limited data sources. We discussed this in the video on the logical problem of language acquisition. Children make decisions about how their language is structured. Is it object-verb or verb-object, based on very few examples. This phenomenon, the phenomenon where children can determine their grammar based on very small amounts of data, is known as the poverty of the stimulus. And it's taken as one of the standard arguments that you need access to universal grammar to constrain the range of grammatical systems that the child considers. So it simply is the case that children don't have access to the same tools that that LLMs do. So it follows then that they may not use the same tools to acquire their sentence structure. Now, will LLMs get better and be able to figure out language structures based on smaller databases? Well, I can't predict the future. These technologies are rapidly advancing, and it may well be the case that LLMs will get to the point where they can actually mimic children's acquisition of language based on small databases. It's already the case that there are many linguists and computer scientists out there who are trying to what we call bootstrap LLMs, that is, help LLMs work on low resource languages. These are languages that do not have large databases of sentences. One of the ways they do this is they actually make use of data from higher resource languages, such as English. So, for example, they sort of take what they learn from English, and then they use that to supplement the information they get from the Scottish Gaelic database. Again, children don't have access to that kind of data source. They don't necessarily have access to a large database that can bootstrap their small data input. Okay, so I think it's reasonable to conclude that children, at the very least, humans need UG, even if LLMs don't. But another problem seems to be that although LLMs produce language that is very, very human-like, it actually demonstrates that it does not have access to structure dependence. So it doesn't have access to abstract structure like the trees we've been drawing. It's only just a string, and a string that's determined probabilistically. So we can ask the question, does ChatGPT have access to abstract structure? Can it draw the same conclusions about the meaning and structure of sentences that we as humans can? So in order to investigate this question, I want to show you a couple of cases where we know that structure helps in the determination of meaning. Let's remember binding theory. Condition A of the binding theory says an anaphor must be bound, which means C-commanded, by its antecedent. Now, C-command is a relationship that is inherently hierarchical and abstract. It's not directly deducible from the statistics of co-occurrence. It actually requires understanding the structure that is imposed upon the sentence. Now let's take a sentence like, I described Mary's cousin to herself. A human will tell you that, who was I talking to? I was talking to Mary's cousin. I wasn't talking to Mary. I was talking to Mary's cousin. Now the reason for that is Mary's cousin, the noun phrase Mary's cousin, C-commands the anaphor herself. Mary does not C-command herself. Mary is embedded inside of that noun phrase, Mary's cousin. Now notice what ChatGPT's response to this is. It responds incorrectly, you were talking to Mary. This is not an answer that a native speaker of North American English would ever respond. This sentence clearly refers to describing the cousin to the cousin, not to Mary. So ChatGPT doesn't understand the hierarchical structures involved in determining the reference of anaphors in binding sentences. Since Mary doesn't C-command the anaphor, it's in the specifier of the complex DP, Mary's cousin, ChatGPT's interpretation is not human-like. Let's look at another example. The sentence, visiting professors can be exhausting, is actually ambiguous in English. It can mean two things. It can mean Going to visit professors can be exhausting. So I go and I visit a whole bunch of different professors at another university, and I'm exhausted. That's one interpretation. Another interpretation makes use of the fact that visiting can be used as an adjective. So there's an expression that a visiting professor, that's a professor who's visiting from somewhere else. Many universities allow professors to come and stay at their institution for a year or two to do special studies or do special research with colleagues. Those people are called visiting professors. Now, the second meaning of this sentence is that when you have someone visiting you who's a professor, they're a visiting professor, they can exhaust you. So that's the other meaning. One meaning is where I go and visit a bunch of professors, that's exhausting. And the other one is where those professors happen to be visiting me, they can be exhausting to me. So let's test this. Let's see if ChatGPT actually can understand that ambiguity. That ambiguity is structural. When it's visiting professors can be exhausting means the case where I'm doing the visiting. Visiting is a verb. It's a gerund, but it's a verb. In the case of visiting professors can be exhausting, where visiting professors is a kind of professor, it's an adjective. So let's see if ChatGPT can get this structural ambiguity. I asked, visiting professors can be exhausting. Does that mean going to visit professors can be exhausting? That's the first meaning I gave you. And ChatGPT denies this. It says, no, the sentence visiting professors can be exhausting does not refer to the act of going to visit professors. It does, of course. That is a plausible interpretation. But rather to the experience of hosting or accommodating visiting professors at an institution. The word visiting in this context means that professors are temporarily visiting or staying at the institution rather than being permanent members of the faculty. Therefore, this sentence implies that hosting or accommodating visiting professors can be tiring or draining. That's one of the two meanings, but it denies the existence of the other meaning, which I think is just as equally salient. This example came from Janet Nickel. The previous example came from David Pizetsky. Okay, here's one more. This is an old observation which was originally due to Carol Chomsky, who was Noam Chomsky's wife. There's a class of verbs that, a class of predicates that are called easy predicates. They have a particularly strange property where the subject of an is easy construction is the logical object of the embedded verb. These have often been treated as a kind of object-to-subject raising. So if I said, this bread is easy to cut, I am cutting the bread. The bread is the object of the cutting. But it shows up as the subject of is easy. This bread is easy to cut. Okay, so let's see how ChatGPT does with this, where we have a movement relation, which is inherently a structural relation. So we set up the sentence and we say, Mary and Sue are talking and Mary is blindfolded. Okay, Mary has a blindfold on. Is Mary easy to see? And the answer to this should be, yeah, probably, because Mary's blindfold does not affect our ability to see Mary. It only affects Mary's ability to see. But we find that ChatGPT gets completely the wrong interpretation. It says, no, Mary is not easy to see if she's blindfolded. When someone is blindfolded, it means their eyes are covered or obstructed in some way, usually by a cloth or a piece of material. This makes it impossible for them to see. So ChatGPT is interpreting Mary as the subject of see, rather than the object of see. Therefore, if Mary is blindfolded, she cannot see anything around her, and she is not easy to see herself. This is completely the wrong interpretation. Mary is the object of see, not the subject of see. So it appears as if ChatGPT, while it produces beautifully coherent prose, like the answer to this question, almost even thoughtful answers, it actually gets the structure of the sentence wrong. It doesn't interpret it the way a human would. Okay, so what are we to make of large language models then? I think here it's important for us to recall a notion that I introduced very early on in the book and in the course, which is the distinction between competence and performance. Competence is what you know, and performance is what you produce. I think large language models are actually clear masters of performance. They do an amazing job. They write poetry, they give these coherent, thoughtful answers to things, but they fail at the most basic tasks of competence. They don't seem to know what we know. They can't make linguistic acceptability judgments. And when they do, they get them wrong. So what we can conclude from this is that they're not actually a replacement for a structural theory of syntax, even if they are remarkably good at mimicking the output, that is, the performance. We can also conclude that they are not human-like in the way they acquire their syntax. They require lots and lots and lots of data, which children don't have. So while LLMs differ in these two regards from generative grammar, if we're thinking about humans, that's exactly the problem. Now, what we have here is a conflict of goals. If we think about what generative grammar is for, generative grammar is to model the linguistic cognition of humans. If you want to know about how a human's linguistic system works, study generative grammar. How do we acquire syntax? How do we learn it? And how do we use it? The goals of artificial intelligence are not the same. They are not to demonstrate how humans work. Instead, what they are is to replicate the behavior of human intelligence using other tools, using computers. They're not really there to describe how humans work. In an ideal world, that modeling that you construct using an artificial intelligence would explain humans too, but it appears that at least for now, that isn't the case. I think it's worth noting that neither of these approaches negate the value of the other. Just because generative grammar is good at describing human cognition, and artificial intelligence is good at replicating the performance of that system, doesn't mean that one or other of them is right or wrong. They're just inherently different. So I think that's one of the problems with the initial question that I started this video with. Do large language models falsify generative grammar? No, they're actually got different goals. They have different purposes. So no, they don't falsify it, and they are not the same. They don't do the same things. My last slide here, I have a bunch of further reading, which again I will link in the comments to this video. Ted Chiang has actually quite an interesting article in the New Yorker about what ChatGPT actually does. Gary Marcus has a couple of articles on ChatGPT and how it does or does not mimic human language. Gary is actually an expert in artificial intelligence, so he has an interesting perspective. And Noam Chomsky and some of his colleagues wrote an opinion piece about ChatGPT that appeared in the New York Times, and you can also find it in other places on the web. So I will link all of those below. I encourage you to read them and also to read the literature on the other side of the question. And I hope you will find this is a stimulating issue, but one that does not falsify the value that 60 years of research in generative grammar has produced.